difference to that of the low latency systolic structure. The processing elements have been clocked. Therefore, the number of the registers can also be reduced, as well as the latency can also be reduced at the final stage. And this is the these are the internal structure of the process, each of the processing elements. That is the first structure. It is the internal structure of the processing element PE of 0, and the second one is the internal structure of PE of 1, and the third one is the internal structure for PE of 2, and it goes on. And the last one is the internal structure of AC, addition unit. And this is the formation of my processing elements. That is, usually processing elements have been there will be 3 registers in each of the processing element. The 3 register includes multiplication register, shifting register, and addition register. For the case of the multiplication register, the gate used is the AND gate, and for the case of the shifting register, the gate used is the BSC, which is nothing but the base shift cell is being used, and for the addition register, the gate used is the XOR gate. And this is how the processing elements are being formed. In the case of the systolic structure, the operation of the processing elements will take place in a serial form. But whereas here, the first multiplication and the shifting operation, and the second multiplication and the shifting operation will be conducting in a parallel form. Therefore, the latency can be reduced at the final stage. In the existing system, for the addition operation has to wait till this multiplication and shifting operation, and this M2 and R2 gets completed. But whereas in our proposed design, these both will take in a parallel form. Therefore, the addition operation it does not need to wait. Therefore, the time can be reduced. Simply, in my proposed system, the registers are being shared in my proposed algorithm. Therefore, the processing elements can, the sharing of the registers has been done by the neighboring processing elements to reduce the register complexity. That is, the proposed system algorithm here I am using is a reducing technique, and the proposed system advantages are less complexity, space complexity, less circuit complexity, low latency, improved cryptographic application in RS encoder. And the software requirement is Xilinx and ModelSim. Here my software implementation, I am going to do it with 2 implementation. One is with Xilinx and the other one is with the ModelSim. In the case of the ModelSim, just I am going to do the design verification, and with the Xilinx software I am going to do I am going to calculate the area and time calculation, and the hardware requirement is my FPGA kit. Finally, I am going to implement it with the FPGA kit, and this is the ModelSim implementation. ModelSim, this is the simulation of the systolic structure using the ModelSim. And this is a ModelSim simulation for low latency systolic structure, and this is the ModelSim simulation for the proposed multiplier. In all these cases, when I give 2 inputs A and B, and the third output which I mentioned here as C will be the same for all the 3 cases. That is the multiplier which I designed it has been verified with this result. And this is the simulation which I have done with the Xilinx. In the case of the systolic structure, the area I have calculated to be 3087 gates have been used in the case of the systolic structure. In the case of low latency systolic structure, the number of gates consumed are 2835 gates are being consumed. Whereas in the case of my proposed structure, the number of the gates consumed is 2772. That is, I have reduced the number of gates used in the proposed structure. Thus, the one section of my project gets completed. That is, I have approved about the area reduction, and next I am going to state about the time delay. In the case of the systolic structure, the time consumed is 21.131 nanoseconds, and in the case of my low latency systolic structure, it is about 16.460 nanoseconds. But in the case of my proposed structure, the time consumed is 16.200 nanoseconds. Thus, the time is also been reduced. And this is my implementation, that is my project application, RS encoder. Here in the case of the RS encoder, the area consumed, that is the number of the gates consumed in my application, that is RS encoder, is about 449, and the time delay consumption in the case of my RS encoder is 8.918 nanoseconds. This is my statistical data which I have calculated using the tabular column.